It is hot out there all over the planet. And so I wanted to check in with Professor Michael Mann on this. He's the Distinguished Professor of Meteorology and the Director of the Earth System Science Center at Penn State University, author of multiple books. The guy who invented the, well, he's the author of The Madhouse Effect, How Climate Change Denial is Threatening Our Planet, Destroying Our Politics, and Driving Us Crazy. His website, michaelmann with 2Ns.net, and you can tweet him at Michael E. Mann with 2 Ns. And Michael, you invented the hockey stick?
You could say that, yeah.
Okay.
20 years ago now.
Cool.
Yeah.
And Al Gore took that thing and you know, popularized it. And boy, your work, you have changed the world, sir. Your work is just extraordinary. I'm
right back at you, Tom. Yeah.
Thank you. I'm looking at an article in Nature. I'm wondering if you saw this. Globally rising soil heterotropic respiration over recent decades, and what their point, they started out by saying global soils store at least twice as much carbon as the Earth's atmosphere. And then they talk about how it's traditionally been a global sink of carbon, and now they say it looks like it's starting to gas out carbon, that this could be a tipping point of some considerable danger. They say all trends are robust to sampling variability in ecosystem type, disturbance methodology, fertilization effects, and mean climate. Taken together, our findings provide observational evidence that global RH is rising, probably in response to environmental changes, consistent with meta-analysis, long-term experiments. And they say that some of this is being driven by increased bacterial activity in soil. You know, we've been talking about this for a long time, you and me, Michael. And back, 5, 6, 8 years ago, I would say wild stuff like, oh my God, what happens if the methane starts melting in the Arctic, or, the soil starts outgassing methane. And, you were a little more laid back. It seems that scientists, and I don't mean that in any negative way, I honor your methodical approach to all this stuff, but it seems that science is starting to get scary. Am I exaggerating here?
No, not at all. And our critics accuse us sometimes, the scientists, of being alarmists because of the what we have to say, because of the problem that we're describing. And you could say that what we have to say is alarming. And the irony here is, if anything, we have been overly reticent. That includes myself at times. We tend to be conservative in terms of our pronouncements because we want to be convinced by the evidence before we state something to be true. Now, on methane feedbacks, there still is a legitimate debate within the climate research community as to how substantial those might be. But this latest article that you describe is a good example of sort of one of these, unknowns, known unknowns, if you will, and an example of how uncertainty has not been our friend, because we are, in fact, learning that there may be some additional positive feedback processes. And that sounds like a good thing, but it's not. The positive feedback is a vicious cycle. It means the problem worsens itself. And in this case, by warming the planet and warming the soils, we're increasing the activity, this bacterial activity, in a way that actually causes the soils from being, as you alluded to, a net sink that's pulling CO2 out of the atmosphere and helping keep CO2 levels lower than they would otherwise be. That appears to be turning into a source. It's actually adding to the CO2 buildup from the burning of fossil fuels. There are other examples of these so-called carbon cycle feedbacks that typically have not been incorporated into climate models. Only in more recent years have climate modelers started to incorporate these processes. And this is an example of why it's been so difficult. We're still doing the basic research necessary to understand these mechanisms so that we can put them in a mechanistic model. Yeah. And here is an example of a study that may cause modelers to reconsider whether we are properly accounting for microbial activity in these models we use to examine the effect of increasing greenhouse gas concentrations on our climate. Yeah. So this is an example of an unwelcome surprise, another example of how things in some sense might be worse than we had thought, not better.
Yeah. The two things I wanted to get your take on right off the top here are, for some time I've been running around yelling about, the Permian mass extinction, a mass die-off. I'm getting a little less hysterical about that and a lot more concerned about civilizational impacts over the short term. What happens when we have millions, billions of climate refugees? We had August 1st, yesterday, was Earth Overshoot Day. It was the day that we surpassed the ability of the planet to produce, to maintain, to sustain itself, essentially, with the net primary productivity. What are your thoughts on the possibility of climate change being a civilizationally disruptive event? That's my first question.
Yeah.
The second one, lest I forget, is it the case that these weather events are obviously the heat is hotter and the storms are stronger and all that kind of stuff, but that the main reason that they're perceived as being even more severe than the increased temperature might suggest, and they're causing things like all these wildfires, is because the jet stream has disintegrated in ways that are causing these weather patterns to move much more slowly than they traditionally used to be. So instead of just one day of 103, we're getting 6 days in a row of 103. Back to you, sir.
Yeah, I'll try to tackle both of those questions at once because they are interrelated. The fact is that you don't have to use your imagination anymore to understand how climate change represents a threat to civilization. All you have to do is turn on your television or read your newspaper headlines. We are seeing all sorts of extremely unprecedented and damaging weather events across the entire northern hemisphere right now, from the wildfires in California to the unprecedented heat in the Arctic and the wildfires up there, to the flooding in Japan, and the list goes on. And these are all interconnected in a way that you've alluded to. Some of this it has to do with basic physics. You warm up the planet, you're going to have more intense and more frequent heat extremes. That's obvious. You warm up the planet, you're going to have a warmer atmosphere that can hold more moisture, so you're going to get bigger rainfall events. You're going to get bigger flooding events. You dry out the soils through evaporation, you're going to get worse droughts as well at the same time, and the list goes on. But there's something else going on here as well, and you've alluded to this. Part of what makes these weather events so extreme isn't just the nature of the weather itself, but its persistence. And we are seeing the jet stream, in a sense, slowing down. And we're also seeing very large meanders in the jet stream where it swings way north. And that gives us what's known as a ridge. And that's where you get a lot of sunlight, you get baking of the soils, you get drought, you get wildfires. And that's what we've got over western North America right now, California. But then that jet stream meander dips south again on the other side of the country. That's what we call a trough. It's a low pressure center. And you get rainfall with that. Well, we've had rain here for, I think, now 7 consecutive days here in central Pennsylvania. And it's part of this large scale system right now, this large scale sort of meander in the jet stream that isn't moving along. And it's a really big meander. So the bigger those ridges, the bigger those troughs, the more wiggly the jet stream, the more extreme weather. The slower the jet stream, the more likely it is that those weather systems remain stalled. They stay in place. And day after day, you get rainfall in the same location, or the heating of the sun day after day in the same location. Our own research has shown that climate change, and in part through the accelerated warming of the Arctic, is actually changing the jet stream in a way that makes these properties more frequent, that makes it more likely that you're going to see these very large meanders, and they're going to stay locked in place for day after day. And when those two things come together, that's when you get unprecedented weather extremes. And we're seeing that play out. And we know, as a matter of fact, that the mechanism that we've described in our scientific articles is actually playing out right now in the pattern we've seen this July.
Wow. Sir, we have about a minute and a half, I think, here before we're going to hit a hard break. The state of pushback, how are we doing, fighting climate change? Obviously, Trump pulled us out of the Paris Accords, but, a lot of companies, a lot of people are still committed to doing something about climate change worldwide. But the Paris Accords weren't binding in any case. Where are we at and what can we do?
Yeah, it's a great question. Where we're at is that the United States right now is the only country in the world that is not committed to the Paris Accord. We are the skunk at the garden party right now under Trump. The Trump administration's policy, as you alluded to, is to threaten to pull out of Paris, whether or not he can really even do that, but to undo a lot of the progress that's been made over decades in acting on a host of environmental problems, including climate change, including all the progress that was made under the previous administration. The Trump administration, his EPA is trying to get rid of the Clean Power Plan, back out of our international commitments, and undo all sorts of regulations that are designed to keep us from accelerating the burning of fossil fuels, blocking incentives for renewable energy, making it more difficult, for example, to sell solar panels to the United States, putting a tariff on solar panels and Chinese solar panels. So across the board, Trump and his, and those he represents, in fact, polluting interests that he represents, have done everything they can to stymie progress here in the United States. The good news is that the rest of the world is moving moving forward. The West Coast states, California, is moving forward under the leadership of Jerry Brown. The New England states, a lot of our largest cities, a lot of our largest companies actually remain committed to our commitments under the Paris Accord. So what that says is we're still making progress. Here's the problem. Paris alone isn't enough to stave off truly catastrophic climate change. We're going to need to improve on the commitments that were made in Paris if we're going to prevent that. This administration seems hell-bent on preventing that. We need to send a signal to the administration and to Congress that we want to join the rest of the world. And how are we going to do that? In less than 100 days now, we've got a midterm election where we can signal we want to join the global community. We don't want the U.S. to be an obstacle. And we have to vote on this issue, on climate.